All right, let's jump into music, but not the kind you're probably used to. We're diving into a world where complex algorithms, where code, can actually write music. I'm talking melodies, harmonies, the whole shebang, all on their own. So the big question is, how on earth does a machine learn to think like a composer? Well, that's what we're going to dig into.
You know that feeling, right? You're deep into a video game or maybe just trying to relax in a coffee shop and you hear it. That same little piece of music. Again and again, on a loop. It starts out fine, but after the 10th time, it just gets grating, doesn't it? Well, that looping problem really boils down to something called linear music. Think of it like a track on a CD. You press play, it's the exact same every single time. Predictable, fixed. But the alternative, now that's where it gets really interesting. It's called nonlinear music. This is more like a live jazz performance. The musicians have a plan, sure, but they're improvising, adapting. It's never the same song twice. And that idea is exactly what we're jumping into in our first section, Beyond the Loop. We're going to look at why that repetition is a problem and explore this whole idea of a better, more dynamic way to think about music.
See, the goal here is so much bigger than just not being annoying. It's about creating music that feels alive. I'm talking about a soundtrack that can actually react and change, in real time based on what you're doing in a game or even just the vibe of a room.
There's this fantastic quote from a researcher named Edo Paulus that just nails it. He wrote that when music and audio adapt to what's happening in a game, it just cranks up the immersion level. It's all about pulling you deeper into that world, making the sound feel just as alive and responsive as what you're seeing. Okay, so how does this magic actually happen? That brings us to section 2, systems that improvise. Let's really look at how you can get a computer to start thinking like a musician. So, the core idea here is something called a musical system. And honestly, the best way to get it is to go right back to that jazz ensemble analogy. The musicians all know the rules, right? The key, the chords, the tempo. But inside that structure, they're free to improvise. A generative music system is pretty much the same thing. It's a set of rules and a toolbox of musical materials, and it just plays within those boundaries. And the whole process breaks down into 3 pretty simple steps. First, you've got sensing. The system has to get some kind of input, say what the player is doing. Then comes processing. This is the brain of the operation, where algorithms take that input, look at the rules, and figure out what music to make. And finally, the response. The system spits out the actual audio that we get to hear.
So what does one of these algorithms actually look like? Well, a classic one is the Markov chain. It sounds complicated, but the idea is kind of simple. It looks at the note you're on right now and then asks, okay, based on my rules, what's the most likely next note? It's a game of probabilities. By chaining these decisions together, it creates musical phrases that sound like they make sense, not just a bunch of random notes thrown together.
All right, that's the big picture. Now let's zoom in and get our hands dirty. Welcome to section 3, composing with code. This is where we see how raw math actually becomes melody and rhythm. A lot of this thinking comes from the work of Carlo Anselmo. He had this brilliant idea to represent melody as pure data. So you have what's called a pitch pattern. It's just a sequence of numbers, like 0, 2, 1, 3. Each number is a note, and just like that, poof, a beautiful melody is now just a simple list of integers. Kind of wild, right? And you can do the exact same thing for rhythm. A rhythm pattern is another list of numbers, but this time it tells you when each note should start. So now you've got 2 simple data sets, one for the pitches and one for the timing, what to play and when to play it. So you might be thinking, how do you get anything complex out of that? Well, let's take a super simple example. A tiny pitch pattern, we'll call it alpha. That's just 2 numbers, 0 and 1. Now watch this. We can apply a math operation called composition to it. Think of it like telling the pattern to grow itself based on a rule. And suddenly, our little alpha pattern becomes alpha squared, which is now 0, 1, 1, 2. See that? We started with 2 notes, and now we have 4, and the pattern is getting more interesting. It's how a simple seed can start to blossom. But the real magic happens when you chain these kinds of operations together. They're called substitution schemes. And this is really the engine room of algorithmic music. It lets a composer take a few tiny, simple patterns and rules and generate these huge, complex, evolving pieces of music. It's all about growth from a simple seed. But hold on, this isn't just about letting a math equation run wild. A human, an artist, is still at the heart of this. And that brings us to our final section, the algorithmic artist. This is all about where human creativity meets the raw power of the machine.
Because here's the thing. The raw stuff the algorithm spits out isn't always, beautiful music right off the bat. It needs a human touch. A composer has to step in and shape it, make it playable. They'll do things like transpose a melody to make sure it fits on a piano, or use something called the modulo operation to keep the notes from flying off into outer space. It's like a sculptor taking a block of marble and carving it into a masterpiece.
So you see, it's not about a composer becoming obsolete and just hitting a make music button. It's a partnership, a true collaboration. The composer brings the taste, the vision, the rules of the game. They set up the jazz ensemble. And the algorithm? It brings this incredible power to explore thousands of musical ideas, to improvise in ways a single human mind just couldn't. Which leaves us with a pretty deep question to chew on, doesn't it? If an algorithm can compose a piece of music that genuinely moves you, that gives you chills, what does that mean for the human composer? What does it even mean to be a composer in this new world?